Lake Lawrence is just one of many lakes in western Washington that is dying. This video is intended to explain why and identify the principal causes. A future video will explain what we have done to operationalize the studies we have commissioned over the years to identify these causes, and what needs to be done in the future to improve the lake water quality and sustain its beauty and recreational benefit for future generations. Subscribe to this YouTube channel by hitting the subscribe button in the lower right corner of your screen so you know what has been done, what is being done now, and what is intended for the future. The Lake Lawrence Lake Management District website at LakeLawrenceLakeManagementDistrict.com provides digital copies of studies, lake surveys, water sampling and testing over the years, and much more. During an agenda-setting meeting on August 16, 2022, in response to staff comments regarding lake management districts, one of our commissioners said this: "I appreciate that. That is what our communities expect. I get very nervous when we think humans can engineer nature. If I have a choice, I would take the natural process." Some would agree with that statement until they learned that our lakes have experienced the most unnatural human activities that have forever changed our lakes. Lake management districts are spending their own money to correct what these activities caused. Human activity greatly accelerated the eutrophication, or the dying, of our lakes in a way that has dramatically increased the production of algae and aquatic plants. Lake Lawrence, like most lakes in our area, was formed several thousand years ago as the Vashon Glacier retreated from the Puget Sound region north into Canada. In 1884, there was a bustling sawmill on the east side. Another mill was operating by the early 1900s on the northwest end of West Lake Lawrence. All the sawdust from these mills was dumped into the lake or piled up near the shoreline. An article in ThurstonTalk.com reported this: in 1905, the Olympia Brewing Company and Olympia Power and Light were locked in a court battle over who controlled flow through the lower portion of the Deschutes River. Both companies were founded in the 1890s along the lower stretch of river, and both had legal claim to some of the flow. Seeing that sharing was the most likely path forward, the Power and Light Company, which supplied power to the city of Olympia, sought another path to ensuring its turbines during the dry summer months.
To provide electricity.
Moving their fight with their beer-making neighbors, the power utility sought to dam a lake in the upper watershed. By creating a savings account of water at Lake Lawrence, Olympia Power and Light would be able to meter outflow throughout the summer. The utility wanted to dig a channel from the river to the lake, and with the help of a small dam, fill the lake in the winter months. Then, after enhancing the dam's natural outlet, let the lake water out in the summer. Unfortunately, that meant they would need to flood land already owned by someone else, so began the process in court to show the company, because it supplied power to the city, had the right to condemn public property to build their canal and dam. After several years of court battles, Olympia Power and Light was finally able to take over Lake Lawrence in 1912. The Olympia Power and Light Company was bought out by Puget Sound Power and Light Company in 1923. The dam on Lake Lawrence continued to function to store water until 1928, when the land was returned to its original owners and the gates of the dam left open. The dam and gates are still in place, as you can see from this picture, but the steel walkway from Pleasant Beach Drive to the top of the dam and the wheel at the top of the dam structure was removed a few years ago for safety reasons. To make all this possible, a ditch was dug from the Deschutes River into the south end of Lake Lawrence, dumping up to 30,000 cubic yards of sediment into the lake annually for over 20 years, greatly expanding the area habitable for aquatic plants. In 1995, Lake Lawrence commissioned a dredging study that showed over 127 acres, or 38% of our 330-acre lake, are covered with over 20 feet of sediment delivered into our lake by the mills and mud sediment that the ditch brought into Lake Lawrence from the Deschutes River. The sawmills and power dam accelerated the eutrophication of Lake Lawrence by as much as 200 years, much like building the dam across the eastern end of Budd Inlet accelerated the death of Capitol Lake. The Capitol Lake project wants you to throw in millions of dollars to maintenance dredge Budd Inlet once the state restores Budd Inlet by getting rid of Capitol Lake. The study shows the Deschutes River filled up Capitol Lake, bringing as much as 35,000 cubic yards of nutrient-rich sediment into the lake annually, resulting in over 13 feet of sediment in some areas, bringing unprecedented aquatic plant growth and uncontrolled algae blooms and other water quality issues, not unlike what happened to Lake Lawrence. Over the years, the this required hundreds of thousands of dollars from the state in unsuccessful attempts to fix Capitol Lake. They finally gave up and now are recommending expenditures of over $250 million to get rid of the lake and restore Budd Inlet. But the state will not invest in restoring other lakes. Just like Capitol Lake, there was nothing natural about what happened to Lake Lawrence. Eutrophication accelerated by human endeavors linked to commerce and building a civilization. I'm not condemning what happened, merely explaining it. Current lake management district efforts are attempting to slow down and possibly reverse some of the human causes that have impacted Lake Lawrence, and to the best of our ability maintain a lake where all Thurston County citizens can enjoy the benefits paid for by lake residents. Since 1986, Long Lake and Lake Lawrence residents have paid over $10 million in assessment fees to pay to maintain our two lakes. The financial benefit to our state and county to maintain healthy lakes can probably be calculated in millions of dollars a year. Our current county and state government need to bear more of the burden for caring for our lakes and fixing the problems our lakes have experienced and are experiencing today as a result of decisions made over 100 years ago that substantially benefited current-day Olympia. The people of Lake Lawrence have done their part and will continue to do their part in maintaining Lake Lawrence, but we need the county and state government to step up and do their part. There has been more and more pushback to state government departments to not support lake improvement projects. This animation video shows the diversion of the Deschutes River, blue line coming into the south end of Lake Lawrence, and then exiting the lake in West Lake Lawrence, where the outflow creek dumped back into the Deschutes River once the dam gates were opened in the summer. The round saw blades popping up on this map show where one sawmill was located on the southeast end of the main lake and the other on the northwest end of West Lake Lawrence. Logs were stored in the lake and tied up in log booms. Some sank, which is why we know where the mills were located. The animation then demonstrates how the water flowing through the canal flushed into Lake Lawrence and spread the sediment throughout the lake. When the mile-long ditch was dug from the Deschutes River into the southeast end of the lake, seen here on the map, the water pushed the sawdust, bark, and other debris that was left by the mill throughout the lake, while simultaneously depositing sediment from the river throughout the lake. This activity contributed tons of organic, heavy, mucky sediment to the lake. Estimates range from 20 to 30,000 cubic yards every year for over 20 years, making the lake 1 to 20 plus feet shallower, depending on where the sediment came to rest. We don't know exactly how deep the sediment is because the radar used during the dredging study could only measure the sediment depth to 20 feet and then could not find the bottom of the sediment in 127 acres of the lake. It could be much deeper. What is known is these areas on Lake Lawrence were filled in by sediment, became much shallower, now only 1 to 6 feet deep, and much more susceptible to aquatic plant growth. Much like what happened to Capitol Lake, according to the Lake Restoration Study, the shallow or littoral areas of the lake shown here on this map make up 38% or 126 acres of the total lake surface. The 1991 study of Lake Lawrence by Raymer, Chin, and Mayo, Seattle, Washington, showed the primary cause of the observed water quality problems and biological impacts to Lake Lawrence was excessive levels of nutrients, especially phosphorus. The study showed that the phosphorus is coming from internal lake sources like logging, farming, sediment from diversion of the Deschutes River, almost 83%, 10% from groundwater or aquifers that are coming up in the lake, and 7% from overland flows and precipitation, which is road runoff, construction, yard fertilizer, pet, and other animal and waterfowl waste, septics, etc. In addition to these two primary examples of human industrial harm to Lake Lawrence, mills and electrical power, other problems have persisted over the past 150 years that have contributed to the challenge we face today. They were agricultural and growth challenges that impacted the lake. From the early 1900s, several large ranches, cattle, sheep, dairy, and chicken bordered Lake Lawrence's southern and western side of the lake. By the 1960s, county and land taxes became a burden for some families with large parcels bordering the north and east shores of Lake Lawrence. So they were subdivided into developments. All these residents had on-site septic systems. County zoning and taxes greatly contributed to the accelerated development of the lake. Although the aerial shoreline analysis, groundwater assessment, and luminology studies show that on-site septic systems contributed negligibly to groundwater contamination, it does have an impact. Currently, 98% of all developable land around Lake Lawrence has been developed. Other naturally occurring contamination has impacted the lake. These include aquatic microphytes or plants that grow, die, and become biomass on the lake bottom have contributed unknown tons of decomposition filling in the lake basin. This excessive growth causes odors, unsightly accumulations, oxygen depletion, and high nutrition release, adding to the toxic algae growth. Fecal chloroform bacteria represents a potential public hazard. Greatly increases nutrients, resulting in increased aquatic plant growth, increased nutrient levels, thereby increased toxic algae growth and algae blooms. The low numbers of fecal chloroform bacteria observed in the well point treatment samples during the study suggest that the adjacent on-site wastewater treatment systems or septic systems are not, for the most part, a source of contamination in nearshore areas. Possible sources of fecal chloroform bacteria in the nearshore area include pet, waterfowl, or other upland on-site wastewater treatment systems near the lake. A study of resident lake waterfowl, that is, waterfowl that do not migrate south for the winter, primarily geese, showed that one goose poops 1 to 1.5 pounds of nutrient-rich excrement a day. For Lake Lawrence, with an estimated resident goose population of 2 to 250, that equates to 2 to 250 pounds of feces a day, or 73,000 to 91,000 pounds a year, or 36 to 45 tons of 7 to 9 5-ton dump truck loads of feces year after year. And that is just the geese. It is no wonder that the lake has fecal chloroform bacteria, increased aquatic plant growth, and water quality issues. As a result of the number of geese and the facts presented, numerous lake residents banded together to raise money and contract with the U.S. Department of Agriculture, who has responsibility over migrating waterfowl, to have them come into the lake area, assess the situation, and remove as many geese as possible. In June 2022, 154 geese were removed from the lake. Water quality during the summer of 2022 improved greatly. Over the past 2 years, the resident geese population has again once grown to approximately 175. Overland flow of contaminants from private property, lawns, and gardens that use fertilizers and herbicides is another area that contaminates our lake. The study showed that this was present in and around the lake. It contributed less than 4% of the annual phosphorus or nutrient load to the lake. The Lake Management District has repeatedly addressed these type of contaminants at annual meetings with guest speakers, newsletters, YouTube videos, and HOA rules. Although we cannot be certain of the total impact of these efforts, we continually monitor shoreline lawns, gardens during our monthly lake surveys between April and September of each year to see who is watering and fertilizing their lawns, and then talking directly to those homeowners and sending them information about the harm they could be causing to lake water quality. We also strongly encourage shoreline owners to plant native vegetation between their home and shoreline and allow vegetation to grow along the shorelines. More and more are doing this. A future video will explain what we have done to operationalize the studies we have commissioned over the years to identify these root causes and what needs to be done in the future to improve the lake water quality and sustain its beauty and recreational benefit for future generations. Subscribe to this YouTube channel by hitting the subscribe button in the lower right corner on your screen so you know what has been done, what is being done now, and what is intended for the future. The Lake Lawrence Lake Management District website, again, is at lakelawrencelakemanagementdistrict.com, and it provides digital copies of studies, lake surveys, water sampling and testing over the years, and much more. Now we will provide you a couple other videos that you may find interesting and expand upon what you just watched.